Alright guys, today we are looking at lesson 9.5, irrational numbers. So our learning target today is to understand the concept of irrational numbers. We should be able to classify real numbers as rational or irrational. We should be able to approximate irrational numbers, and we should be able to solve real life problems involving rational numbers. Okay, so what is an irrational number? An irrational number is anything that is not rational. Okay, so if we cannot write it in a fraction form, okay, then it is irrational. So the square root of any whole number that is not a perfect square is irrational. The cube root of any integer that is not a perfect cube is irrational. And pi is also irrational. Okay, every number can be written as a decimal. The decimal form of an irrational number neither terminates nor repeats. Okay, that means it doesn't stop and it doesn't have a pattern to it. Okay, so this key idea here, this chart is very helpful to help classify. So if we were looking at this, the blue circle are examples of a rational number, right? Cubed root of 7, we don't know that. Square root of 2, we don't know. The negative square root of 3, we don't know. Pi is irrational, and if we're multiplying pi by something, right, that would still be irrational. Rational numbers, on the other hand, right, those can be written as fractions, right? Those are decimals that terminate or decimals that repeat, okay? So 2.25 stops, 0.3 repeating, has a repeating pattern to it. An integer, okay, is a little more specific, right? Those add our negative numbers, okay? So -1, -2, -3, -4, and so on. A whole number adds 0 to that classification, and then natural numbers adds our counting numbers to that. Okay, so if we were going to look at some examples of classifying numbers, our first one here is the square root of 12. I do not know what the square root of 12 is, so it is irrational. Right, because 12 is not a perfect square. Okay, negative 0.25 repeating. Right, that's going to be rational because it's a repeating decimal. Negative square root of 9. So I know that the negative square root of 9 equals negative 3, and negative 3 is an integer. And I'm just going to write that. Negative square root of 9 equals negative 3. Cube root of 15. I do not know what the cube root of 15 is, so that is irrational. Okay, and then pi, right? Pi is also irrational. The decimal neither terminates or repeats. Okay, so go ahead and try these ones below. If you want to pause the video really quick to try those, go ahead, and then we can go through those answers. All right, so if we were looking at the first one, this decimal continues on, right? It's not terminating, and our pattern is not repeating, right? Because it goes 1, 2, then 2 2s, then 3 2s, right? So we don't have a pattern that's repeating, so this would be irrational. The negative square root of 196 is equal to negative 14, making this number rational, but more specifically, right, it's an integer. Okay, so integer would be the best way to classify that, right? Because if you know it's rational, okay, then we can go one more step to say that that's an integer. And then the cubed root of 2, right, I don't know the cubed root of 2, so that would also be irrational. All right, approximate the square root of 71 to the nearest integer, and then to the nearest 10th. Okay, well, square root of 71, I can see that it fits in between the 8 and the 9, and the square root of 71 is a little bit closer to the 8, right? Because 71 to 81 is 10 units apart, but 64 to 71 is only 7 units apart, right? So it's a little bit closer to the 8. Okay, to the nearest 10th, well, again, 71 would fall between 8.4 and 8.5, and it's a little bit closer to 8.4. Okay, so if you didn't have this chart with you, you can figure out those decimals, right, by multiplying some of those pieces out. So you could have done like 8.4 times 8.4, right, and 8.5 times 8.5 to see where they fall. And how do you know 8.4 and 8.5? Well, you got to play with those numbers a little bit, okay? So knowing that 71 is between 8 and 9, but it was kind of in the middle, but a little bit closer to 8, right? So kind of in the middle would be 8.5 would be the middle, right? But it's a little bit lower than that, so 8.4 would be a good guess to start. All right, so let's try some of these ones, right? Now we don't have that chart. So again, if I'm looking at square root of 8, okay, that's between, right, I know that the square root of 9 and the square root of 4, which, right, square root of 4 is 2, square root of 9 is 3. So I know that square root of 8 is between 2 and 3. But obviously it's a little bit closer to 3. Okay, so then since I know it's closer to 3, I'm probably going to guess numbers like 2.8 or 2.9. Okay, to figure out which one's closer to. So I'm going to go ahead and multiply those out to see. So if I did 2.8 times 2.8, right, that would give me 7.84. And if I did 2.9 times 2.9, that would give me 8.41. So 2.8 ends up being a little bit closer. Okay, so same idea for that next one. So if I'm looking at the square root of the negative square root of 13, right, that's between the square root of 9 and square root of 16, which means it's a little bit closer to negative 4. And then if I looked at my decimal, it's kind of in the middle, right, but a little bit closer to negative 4. So I would probably want to look at decimals like negative 3.5, negative 3.6, okay, something like that. And if we tried those out, let's see, 3.5 would give me a 12.25, 3.6 gives me 12.96. Okay, so obviously that one's the closest. Okay, so negative 3.6 would be our answer there. All right, negative square root of 24. Okay, that is pretty close, right, to negative 5, right, because negative square root of 25 would be negative 5. Okay, so again, I know it's pretty close to negative 5, but it's a little bit lower, right? So I would probably go with like 4.9, maybe even 5 would be the closest. Okay, so if we multiply 4.9, .9 would give us negative 24.01. Okay, so it beats out 5 just a little bit. So negative 4.9 would be the closest there. All right, and then square root of 20, right? That's between square root of 16 and square root of 25. Okay, so that's a little bit closer to 16. Again, that's kind of in the middle. So I'm going to try like 4.5. And it's a little bit lower. So maybe 4.4. So 4.4 times 4.4 gives me 19.36. 4.5 times 4.5 gives me 20.25. So 4.5 is closer. Okay, which is greater, the square root of 35 or the cubed root of 80? Well, the square root of 35 is going to be between, right, 25 and 36, right? So it's between 5 and 6, obviously a little bit closer to 6. The cubed root of 80, let's think about some cubes that we know. The cubed root of 81 and the cubed, oh, that's a square root, I know. Oh, hello. All right, that would be the cubed root of 125 and the cubed root of 64, right, which is 4 and 5. Okay, so which one's greater? Right, I can see that this one's greater because that one's closer to 6, where the other one's between 4 and 5. All right, so same idea for these triads here, and these will be our last ones for today. Okay, so if I am comparing, well, I know pi, so that makes that easy, but square root of 8 is between square root of 9 and square root of 4, which means it's between 2 and 3. And I know that pi is 3.14, so pi is greater. Here, square root of 26 is about 5, right? The cubed root of 65 is about the cubed root of 64, which is about 4. Okay, so the square root of 26 would be bigger. All right, and then last one here, the negative square root of 2 is going to be between negative 4 and negative 1, right? So it's between negative 2 and negative 1. And then the cubed root of 10 would be between, well, the cubed root of 8 and 27. Right, because that would be between negative 3 and negative 2. So which one is greater? Well, that would mean square root of negative 2 is greater, right? Because between negative 2 and negative 1 on a number line is closer to 0 or further right, making that the greater number. All right, guys, that is it for today. We will come back